NVIDIA has been telling us ray tracing is the future of gaming since 2018. 8 years later, here's where we actually are. Only 5 of the 21 most popular PC games from the last year actually use hardware ray tracing. The most visually impressive ones that do, well, they need AI upscaling and AI frame generation just to run smoothly. And the flagship cards NVIDIA uses to demo what ray tracing should look like, the 4090 and the 5090, are owned by less than 1% of Steam users. So if RTX was supposed to make ray tracing normal, then why hasn't it happened yet? When ray tracing is done right, the visuals are genuinely impressive. The question isn't whether it works, it's what it costs for you to use it. It's the gap between what NVIDIA sold us and what most gamers actually got. RTX wasn't pitched as a niche showcase feature. NVIDIA called real-time ray tracing the holy grail of our industry, and said that there was little to no doubt ray tracing is the future of gaming.
When you look at this, what we consider the holy grail of computer graphics, you see some effects that today are simply impossible to create.
Ray tracing renders scenes by simulating how light travels through them, bouncing off surfaces, casting shadows, creating reflections. Traditional rendering approximates those effects using techniques that have powered games for decades. Ray tracing, on the other hand, actually traces individual rays of light, ray by ray, so those effects behave the way that they would in real life. The result, when it works, looks dramatically more realistic. The catch is that it's hugely demanding on the hardware, which is why NVIDIA added dedicated RT cores to RTX cards to handle it. Now, there is a difference between hardware ray tracing and software ray tracing, like what Unreal Engine 5's Lumen system does. Lumen uses ray tracing techniques, but does most of the work in software, and Epic ships it on by default in UE5 games. So, in one sense, ray tracing is everywhere now, but that's through Lumen. And that's not really what NVIDIA was selling. NVIDIA sold hardware ray tracing on RTX cards. That's the specific promise that we're looking into. So, how did they deliver? In February of this year, PC Gamer ran the numbers on 21 of the most notable PC releases of the previous year. Out of those 21 games, only 5 used hardware ray tracing. Now, to be fair, some of those misses make sense. Mugenics, Dispatch, Hollow Knight Silksong, those games, they were never going to use hardware ray tracing to begin with. So, if that's what the list was made up of, then the stat, it wouldn't really mean much, would it? But the interesting part is the games that are on the list that were trying to be visually ambitious. So if you look at Stellar Blade, Split Fiction, Neo 3, Borderlands 4, these are big, graphically intensive AAA games, exactly the kind of releases that NVIDIA would want to showcase. None of those use hardware ray tracing. Monster Hunter Wilds only uses ray tracing for reflections, and here's the one that I think says the most. Battlefield 5 was one of the first games NVIDIA used to showcase ray tracing back in 2018. Battlefield 6 launched in 2025 without it. So 7 years later, the franchise NVIDIA literally used to sell ray tracing to gamers walked away from it completely. And that's honestly the part that should bother NVIDIA the most. 8 years of marketing, and even the games that should be using ray tracing, as it's kind of their natural home, they're not bothering with it. And it's not because the technology stopped progressing. The technology did get better. It has gotten better. The problem is that the audience just never caught up. Look at the latest Steam hardware survey. The most common gaming GPUs on Steam right now is the RTX 3060 at about 4%. The RTX 4090, the card that NVIDIA was using to demo what ray tracing could be, sits at 0.74%. The RTX 5090 is even lower at 0.41%. The cards that actually push ray tracing the way NVIDIA's marketing showed it, less than 1 in 100 PC gamers actually owns one. Now, of course, flagship cards are always going to be rare. That's not the surprising part. The surprising part is that 8 years in, ray tracing of that quality is still flagship only. So yes, mid-range cards, they technically have ray tracing and you can turn it on, but the performance hit is steep enough that you're either taking a major frame rate cut or you have to lean heavily on DLSS and frame generation to claw that performance back. And for most people, that trade-off just isn't worth it. So technically, the feature is there, but practically on the cards that most people own, it might as well not be. So the showcase examples, Cyberpunk Path Tracing, Alan Wake 2, Black Myth Wukong, they look good, but they are demos, viewed by a small slice of the audience on the most expensive consumer GPUs ever made. Relying on NVIDIA's AI technologies like DLSS and frame generation is become a bigger problem than ray tracing itself. It's about a pattern in how NVIDIA markets cutting-edge graphics and how the rest of the industry actually adapts to it. So every few years, NVIDIA introduces a new tier of graphics technology as the showcase. Ray tracing on the 20 series, then path tracing, now there's neural rendering on the 50 series. But each tier gets demoed on the latest flagship to prove the technology has arrived. Take Cyberpunk's path tracing mode, the most demanding ray tracing in any current game, and NVIDIA's go-to showcase. Tom's hardware tested it on a 5080 at 4K. You're getting 36 frames per second. Multi-frame generation pushes that displayed rate higher, but those frames are interpolated. So the game actually feels like the DLSS rate, which is still under 60, not the bigger number on the screen. It's the flagship tier. But look what's happening to the regular ray tracing, the version that NVIDIA has been selling since the 20 series, back in 2018. 8 years later, mid-range cards still need DLSS to make it playable. NVIDIA explicitly markets RTX 5070 as a 1440p gaming card. Alan Wake 2 at 1440p, even with upscaling, came in at 39 frames per second, which TechSpot called, quote-unquote, a disaster. And that's not just Alan Wake 2. Black Myth Wukong and Cyberpunk 2077 show the same pattern on the 5070, a 1440p modern AAA game with ray tracing on, native, still struggling to hit 60 frames per second. And upscaling is required to make any of them playable at the resolution that NVIDIA sold the card for. That's the card NVIDIA built specifically for this resolution, and even it cannot deliver the feature that NVIDIA spent 8 years trying to promote at that resolution. The version of ray tracing that NVIDIA originally promised should be running comfortably on a card like that by now, and it still just doesn't. So you've got two layers happening at the same time. You got the flagship showcase needing AI to function, and the supposedly mature feature underneath it, which is regular ray tracing from 2018, also still needs AI to function on the cards that most people own. And here's the part that bothers me the most. DLSS and frame generation were marketed as tools to make demanding features like ray tracing playable. But once those tools existed, the incentive structure for developers also shifted. Some studios started leaning on upscaling to cover for optimization that they don't finish. Monster Hunter Wilds launched in early 2025 in a rough state, leaning hard on upscaling just to feel playable. And it took massive backlash and over a year of patches before Capcom got it running well. Borderlands 4 launched the same way in late 2025. Gearbox's own answer to the performance complaints was to point players at an upscaling optimization guide. 7 months later, they're still patching it. The upscaling is what let both of those games limp out the door in that state to begin with. So AI became a crutch for ray tracing and a crutch for the gaming industry's optimization. DLSS upscaling is a very useful technology. It does what it says it does. I like the technology. But it's now doing structural work that used to be handled by hardware progress and, of course, game optimization. Both have slowed down because AI was there to fill the gap for it. Think about how you actually shop for a GPU. I have never once heard anyone say that they're upgrading their GPU because they want to enable more ray tracing. It's always about performance and resolution. The other part is that VRAM matters more for ray tracing than almost any other feature. Ray tracing eats memory. Path tracing eats even more memory, which makes NVIDIA's own behavior on VRAM after the 30 series pretty strange. If you genuinely believed that ray tracing was the future of gaming, that this was the reason to buy your cards, you'd be raising the VRAM floor on every new generation to make sure that those cards could actually deliver on it. Modern AAA ray tracing games regularly need 10 gigabytes or more, and at higher resolution, that number just keeps climbing. So the obvious move to make ray tracing the future is to make sure that your $500 card can run the thing that you've been selling for 8 years. People wanted better performance. NVIDIA instead decided to sell ray tracing. They built the entire RTX Premium around a feature most people weren't asking for, a feature that most of the games people actually play still don't even use on hardware that almost nobody owns. So the future of gaming, turns out it was something else. It wasn't ray tracing.